Good morning everyone, I want to show you the tutorial vid of the riding on the wind. Watch well.
Newton's second law of motion, force and acceleration. Components of force. The experiment we're going to conduct is called riding with the wind. The purpose of this experiment is to investigate the relationship between the components of the force that propels a sailboat. But first, we must gather the necessary tools and materials needed. 1. Dynamics cart fitted with an aluminum or cardboard. 2. Protractor. 3. Electric fan. 4. Ruler pulley. 5. Mass hangers. 6. Set of slatted masses. But since we don't have the mast hangers and set of slatted masses because they are pricey to purchase, we just improvise instead of mast hangers. We use plastic bag. Then we prepared total of 1 kilogram of cat food and divided it into 10. Each plastic that contain cat food has mass of 100 grams in order to replace the necessary slatted masses. And last one is number 7, string. We use yarn instead because that is what we have that moment. Discussion. In this experiment, we will use a small model of a sailboat and an electric fan. The physics of sailing involves vectors, quantities that have both magnitude and direction. Such directed quantities include force, velocity, acceleration, and momentum. But in this experiment, we will be concerned with force vectors. In figure A, a crate is being pulled across a floor. The vector F represents the applied force. This force causes motion in the horizontal direction, and it also tends to lift the crate from the floor. The vector can be resolved into two vectors, one horizontal and the other vertical. The horizontal and vertical vectors are components of the original vector. The components form two sides of a rectangle. The vector F is the diagonal of this rectangle. When a vector is represented as the diagonal of a rectangle, its components are two sides of the rectangle. In figure A, a crate is being pulled across a floor. The vector F represents the applied force. This force causes motion in the horizontal direction, and it also tends to lift the crate from the floor. The vector can be resolved into two vectors, one horizontal and the other vertical. The horizontal and vertical vectors are components of the original vector. The components form two sides of a rectangle. The vector F is the diagonal of this rectangle. When a vector is represented as the diagonal of a rectangle, its components are two sides of the rectangle. The keel of a sailboat is a sort of fin on the bottom of the boat. It helps prevent the boat from moving sideways in the water. The wind force on the sail can be resolved into two components. One component, K for keel, is parallel to the keel. The other component, T for the tip, is perpendicular to the keel, as shown in figure B. Only the component K contributes to the motion of the boat. The component T tends to move the boat sideways and tip it over. Any boat with a sail can sail downwind, that is, in the same direction as the wind. As the boat goes faster, the wind force on the sail decreases. If the boat is going as fast as the wind, then the sail simply sags. The wind force becomes zero. The fastest speed downwind is the speed of the wind. A boat pointed directly into the wind with its sail at right angles to the gale is blown straight backward. No boat can sail directly into the wind, but a boat can angle into the wind so that a component of force K points in the forward direction. The procedure of going upwind is called tacking.
Step 1, trial 1.
Position the cart with its wheels, the keel parallel to the wind from the front.
Step
Then
1,
we
trial
position
2.
the sail perpendicular to the wheels. After that, start the pump
Step 1,
blowing on the floor
trial
of the
2.
cart with the wind parallel to the wheels. Question:
Step
what
1,
happens to
trial
the
1.
cart? When we start the pan, the cart moves forward.
Step
Step
2.
2. We direct the wind from behind the cart and parallel to the wheels, keeping the sail perpendicular to the wheels. Question 2. How does the cart move?
Step
The
2.
same thing occurred in step 1 in accordance what we observed during our experiment. The cart rolls ahead when we operate the electric fan.
Step 3. We reposition the sail at 45-degree angle to the wheels, and then directed the wind behind parallel to the wheels. Question: what happens to the cart? At first, the cart appears to be resisting the wind, but after a few seconds, the wind tipped it over. Step 4. This diagram demonstrates the wind force perpendicular to the sail. The interaction force is perpendicular to the flat surface. Let's examine the components T and K. The component K that is parallel to the keel is what propels the boat forward. Component T is ineffective for moving the boat forward and merely has a tendency to tip it. The dip keel compensates for this component T. Step 5. We repeat step 3 with the fan perpendicular to the wheels. Step 6. We repeat step 3, but this time we directed the wind at 60-degree angle to the wheels from the front. Question: does the cart sail against or with the wind? What happened to the cart that the wind has a 60-degree angle to the wheels from the front was first it tilted. The wind moved it until it swayed and fell on the table. So the answer is the cart sail is against to the wind. Step 7. We set up the pulley on the edge of the table to prevent it from getting in the way. We attach the pulley to the door using electric tape after stringing it together with the door latch. Then, we attach one end of a piece of lightweight string like yarn to the cart and thread the other end over the pulley. After that, we also attach our improvised mast hanger, which is a plastic bag, and we tied it to the end of the yarn. Next is, we place the fan directly between the pulley and the cart so that the full force of the wind strikes the sail at 90 degrees. Holding the cart, we turn the fan on its highest speed setting. The wind force depends on how close the fan is to the sail. So, we place the fan close to the sail. Then after that, we slowly add very small masses our divided 1 kilogram of cat food to improvise the mast hanger, the plastic bag. We continue adding them until the weight of the masses balances the wind force of the cart. The wind force is balanced when adding the smallest ones, mass, and we have caused the cart to move toward the pulley, and removing the smallest mass causes the cart to move away from the pulley. Lastly, record the mass required to balance the cart. we recorded the mass of cat food we have 500 when we experiment. Overall, it equal 500 grams to balance the cart sailing to the wind. It equal to 0.5 kilogram. And to convert it to the weight, we have 0.5 kilogram times 9.81 meter per second is equal to 4.9 Newton.